So when it comes to client server applications, all right, so let's say this is client and this is server. Now, when it comes to starting communication between these two, what client has to do is initiate the connection. And always please remember, servers are listeners. Right? Servers, what servers does is they are listening to the network or system, right? So now let's say port 80 or www traffic. So www traffic meaning is server listening to the network through port 80. If it is HTTPS, the meaning is server listening through port 443, right? So now let's say client server communication, and this is my client and this is my server. And then in order to establish a connection, I'm not talking about HTTPS traffic or encrypted traffic, but in order to start the communication, we need to do something called three-way handshake. Three-way handshake involve sync, ACK, and ACK, right? So there are 6 types of the packets within a TCP IP packet format. Now, if I show you that, now if you take the packet TCP IP packet, it has 32-bit, right? Within 32-bit, yeah, okay, start working now. All right, so let me just explain the TCP IP packet first. All right. Now, this is the packet. Let's say this is my TCP packet. Here we have 0 to 32-bit TCP packet header. So we have a few information here. There we have source IP, right? Source IP, which is 32-bit. And we have destination IP, again 32-bit, right? So here we have 0 to 31, which means we have 32 bits, right? And then we have another two 16-bit allocations for source port and destination port, right? So these are having 16-bit each. Now the amount is 2 to the power 16 is somewhere around 635,335. As I remember, right? So this is just, I'm not very sure about this figure, but 65,535. So these are the port, this is the port range that we have. So out of which 0 to 1024 is allocated or known as well-known ports or well-known ports. And after 1025 to 65,635 is there for us to allocate. So what is port? Port is an interface, right? In your systems, you would know that we have printer ports, we have USB ports, PS2 ports, various types of ports. The reason is the port is an interface. Let's say USB port, it's an interface. So you can have a USB devices where you can plug it up. You don't have to, verify it's a square type, interface and all these stuff, because everybody knows what is USB. It's an interface. Now, when it comes to TCP communication, we have logical ports. It's not, you can't touch and you can't feel it, but it's a port to communication. The reason is, now if you take a host, right? So this is a host, and host has an IP address. Let's say 192.168.1.5 for an example. So this is an IP address. So then any packet generated can be sent directly to this address. But the thing is, single host can have multiple services running. Let's say this particular host has www traffic and FTP traffic and telnet traffic, right? And then again, it can have SSH traffic. So number of, the services, but single IP address. How we are going to differentiate traffic from each and every service? The technique that we use is ports. So within an IP address is assigned to a host, and we are running certain services, right? Services are known as www service, HTTPS service, which is 443 port. So these are the ports, right? These are actually logical ports. Now, when it comes to scanning, what we use is this technology or this mechanism. Now, you know, this is our packet header. So packet header has information related to source port, destination port, host, source port, destination port, right? Source IP, destination IP, source port, destination, and also there are very important set of bits allocated as a flags. There are 6 flags, right? 6 flags are there. So namely, these flags are SYN flag, FIN flag, urgent flag, reset flag, push flag, right? FIN flag. So FIN, reset, SYN, ACK flag, right? So there is another one called ACK. So these are actually flags, which means each and every flag there is a allocated bit, single bit. What is bit? 1 or 0, right? So if you have FIN, meaning flag is up, flag is on. SYN packet, flag is on, right? So now when it comes to communication, now I hope you understand up to this point. Let's say, let's go to another canvas. Now my earlier picture. So we have a client here, right? This is my client. And here we have a server, right? Server is, remember, always listening. So this server, same server can listening using port 80 and can listen port 443, right? 21, which is FTP, and SSH 22. So likewise, you can have multiple listeners. So they are listening using specific process. FTP process can be Qt FTP, can be FileZilla FTP, or can be internal IIS FTP. So it's listening. Now, when it comes to start the communication, client has to reach or approach respective port. Now, let's say we are talking about port 80, right? Now, our client is browser. Browser send something called sync packet. This is known as sync packet, right? So earlier we discussed about 6 packets, SYN, flags, sync, ACK, FIN, reset, push, urgent, right? These are the 6 flags, right? Now these flags are having their own technique or own mechanisms. Now, for an example, SYN packet always denotes that we are going to initiate a connection. Acknowledgement packet denotes that this is the acknowledgement for the previously sent sync packet. FIN meaning we are going to terminate the session. It's finished, right? No more. You don't have to expect any more packets. And then reset packet is you have not received proper packets. Please send it again, right? Push packet is you need to clear the buffer. And then urgent packet is you need some priority. So these are each and every packet will have certain flags on, right? I hope you understand that. Now, when it comes to start a communication, right? The browser has to initiate it, or any client. So in this case, we are talking about port 80 or 443, then browser. So it can be even FTP traffic, FTP client, or it can be even SSH client. It can be telnet client. So whatever the client, it has to send first request to initiate the packet. It's something like whenever we meet someone or a friend, we say hi, hello, right? And again, friend also says hello, and then we initiate the connection. It's like hello, hello, right? So 3-way handshake is this. So first, client sends the sync packet, and then server send an acknowledgement packet for this sync packet. So when I say hi, server also say hi. So that is how we are starting the communication. Now, just imagine for single server, there can be millions of requests at a time. Then how are we going to differentiate? Now, let's say we have 4 people in this class, and then everybody started saying me hello, right? I also need to say hello, but each of you should understand to whom I said hello, right? But in this communication, it's broadcasting involved, and everybody receives this and all that. But when it comes to server communication, it has to be more specific. So because of that, with this packet or sync packet, we are sending something called a sequential number. sequential number. Now it's a randomly generated 32-bit packet, 32-bit number, sorry, not packet. So within the packet, we encapsulate this. It's a 32-bit number. So you can see it's a huge random number. So the reason is, let's say, easy to understand, I'm saying it's 102. I'm sending sync packet with sequential number 102. Whenever a server receives this, server send an acknowledgement packet saying that when I say hello, server has to also to say hello. With this, it sends a sequential number with 103. Then client knows, okay, this acknowledgement was to the previous sync packet, because always responsive acknowledgement packet will carry sync packets sequence number +1. So in that case, I send sequential numbers 102, then I will receive 103, right? And then with this, server also send a sync packet with another sequential number, let's say 405. And then client has to say send acknowledgement packet with 406, because here we have 405 for the sync packet. So this is known as three-way handshake. Now we would see it's a three-way 1, 2, 3. There are three steps. Client has to say, always client has to start, because server is always listening. Client says hello, 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 right? Now we are ready to start communication. Now, why I was explaining this, the reason is I wanted to explain how scanning works. Scanning is to understand. Now I explain any host can have up to 65,535 ports, right? So any server can have up to 65,535 ports. And then at any given time, all 65,000 ports can operate, right? We don't know. If you have proper services, you can, but in a in general terms or in general situation or typical situation, you wouldn't find even more than 10 ports opening, because that is the number of that is the number of processes running simultaneously to create a port. And then I hope you understand this one. So once your communication is completed, you can start communicating after this initiation. So it's something like we say hello, 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 and then we start communication. How is the weather and where are you from? All this stuff, right? So something similar to that. So when it comes to scanning, we want to understand what are the open ports and what are the processes that are running or that are created these ports. So these are the important areas. Now, in order to scanning, so scanning is to understand open ports. We use the same technology. So we can use multiple a range of tools to perform that. So whatever the tool that we use based on three-way handshake. So there are mainly two types of scanning, right? One is known as full scanning. Other one is known as stealth scanning, right? Stealth scanning, right? I think stealth scanning. So full scan, we complete total three-way handshake. We send sync packet, acknowledgement sync, completed the handshake. Then we know exactly what we know. We know exactly the port is open because port responded. We send sync packet. The moment we receive a response, meaning port is open and operative, right? Now, but stealth scan, we will not complete the three-way handshake. We send say hello and server send hello, like sync act. That's it. We are not going to send acknowledgement again. We are not completing this. Then what is the difference? Difference is when you complete the handshake, the connection is established, right? It will be recorded in multiple places. So when it comes to administrative point of view, if you want to find out the ports are opening, you don't have to worry. Then you complete the three-way handshake. But when it comes to attacker's point of view, I always told you, we need to reduce the noise. We don't want people to know that we are scanning, right? Then what we would do is we send sync packet and we receive the response. Then we know exactly, right, port is open. That's why it's responded, right? So we don't want to complete it. We send reset packet. That's it. Then you will have a question. All right, so we we didn't complete three-way handshake, but we sent a sync packet, right? And we received sync acknowledgement packet. So then we already, identified, right? So because the server sent the acknowledgement packet, but in real communication, there are millions of packets, millions of, packets initiating, or millions of sync packet being received. With all these, considering all these facts, server will not have any attention for the packets which they have not completed the three-way handshake. In that case, we are safe. So when it comes to vulnerability assessments and penetration testing, we usually use a stealth scan or half scan, also known as half scan, because we have not completed the scanning. I think you understand the theory or technology. And then there are multiple tools that you can use to do this scanning. So first one I would like to show you before this. Let me just minimize my Kali. Right. So there's a one tool I would want to introduce you that is known as Angry IP Scanner. Probably you might know this. This is the one. So this is not actually scanner, but it works on top of ICMP traffic, right? I think you know what is ICMP. So ICMP is a protocol we use to, troubleshoot even our usually used ping command built on top of ICMP. So that is created because IP technology or IP layer doesn't provide any response. So when it comes to troubleshooting, it's really hard to do it because IP packet itself doesn't have any a method to troubleshoot. So ICMP is a special protocol that it produces the response error codes. So based on these codes, we can identify what's wrong with it, right? So then we use that. So in Angry IP Scanner worked on IPv6, ICMP packets. So let's say, what is my IP first? Let's find out what is my IP, right? Sorry, IP config. All right, so my IP is 192.168.1.3. So let's try 192.168.1.1 to 1.100. So if I search it, it will, what it does is actually, it performs ping sweeping. Ping sweeping is it tries to ping the range, and whenever it receives the ping response, it says, a host is running. So you would see here the number of hosts are running here, and then even this tool is capable of conducting public IP penetration or public IP, testing. So let's go and have a look here. I'm going to type what is my IP. So Google should respond me. So this is my IP is 58.179.181.49. Right? Let me just open up my Angry IP Scanner. Now I'm going to say, let's say I'm going to say search for until 100, right? To save some time. Now it sends my public IPs. So it sends packet, and whenever it receives, it show me this information. So let's see. Now this is 61, and this is my host name, right? So you can find out all this information here. Let's say we are going to scan till 254, starting with 1. So you can do that here. Angry IP Scanner, you can download. It's a free tool, completely free tool. So you can perform ping sweeping, right? There you would see red color ones are hosts that are not responding, which means possibly hosts are down. And also remember, ICMP protocol can be easily blocked by firewalls, right? So in that, when that happens, so you would see, here and there hosts, right? So there's another one, right? So remember, ICMP protocols can be easily blocked by firewalls. So then when you block ICMP traffic, your ping wouldn't work, including our Angry IP Scanner. So in that case, there is another tool which uses, works on TCP layer known as HPing3, right? So if you want, you can download a HPing3 that is inbuilt within Kali. So even ICMP traffic blocked, you can use HPing3. because HPing3 uses TCP protocol, not ICMP. I think you're clear with that. So then I'm going to show you another one. All right, using Kali. Let me log into this. The tool that I'm going to use is, right. So I'm going to use is Nmap, right? It's a really powerful tool, and if you search anywhere Nmap, this is one of the leading tools, also known as tools for Swiss knife tools, which means any attacker would use this. So Nmap, this is a command line one. Let me search for one of the IP addresses. I'm going to let me just clear it up. Nmap -pn. Pn means no ping, which means we know exactly this host is running and up, right? Hping, and I'm going to say aggressive scanning, and tn is to scan simultaneously. And if I want to, I can say O means operating system detection, and then if I want to, I can specify ports as well. Now I'm going to say the IP address 192.168.1.3 for an example, right? Sorry, N4. I can't recall this.
Excuse sir.
Okay, Nmap. I'm going to say PN and T4. Sorry, aggressive scanning and O. Aggressive scanning and O, right? And then I'm going to type 168.1.3. Right, so it should perform the scanning. So it's command line, and if you want to find out information, Nmap --help, it will give you huge set of information, and it's really powerful tool, and you can start scanning. And then some people are not very familiar with the command line. I would like to introduce another tool known as ZenMap. So you can download ZenMap. Let me just show you this. ZenMap, this is Windows version of Nmap, right? So you can download this from nmap.org, a GUI scanning tool. So let me show you this. I have already downloaded this Nmap. So this is the one, right? So my Kali scanning is working on, right here. I started scanning in my local computer. I open up ZenMap, right? So this is Nmap.org, right? So I'm going to do the same thing. I'm going to perform the same scanning using ZenMap. Let me just a little bit make it smaller, because yeah. So this is the one. And here, if you notice, there are a number of profiles available, right? So you can see intent scan plus UDP. All TCP ports, intent scan no ping. No ping is I told you, right? So when you select this, you would get this switch, right? And this entirely work on Nmap command line, right? So then you can use this one. Let me just so I think you notice that same set of switches that I've used, right? So let me type 192.168.1.1. I'm going to scan it now. Let me start scanning. And I started scanning. Yeah, it's scanning now. So you would see the same command I used in my command line Kali interface, right? So it's running, right? So it started completing running, and let's see what is the output. So, and also I hope you understand the technology, scanning technology, right? There are some other scanning types as well, like Christmas scan, full scan, half scan, null scan. Null scan is without enabling any switch, you are scanning. So there are multiple scans, but mostly used scan is stealth scan or half scan and full scan. Now you would see it discovered already set of ports, right? 443 is HTTPS, and this is how you gather information again, right? 443 is HTTPS, and port 80 website web traffic should, web is working. Now let's say this gives a notification of port 80 open, meaning there should be a web service, right? Let's go and have a look, right? So this is how you can find information. Now let's say my IP is 192.168.1.1. Yeah, that is a gateway, right? So that's why, because I'm scanning my gateway, it's Huawei home gateway. How I know, how I get to know that there is a website? Because this tool return port 80 is open. Port 553 meaning DNS is running, right? And port 443 meaning HTTPS is running, right? HTTPS is running. So let's have a look there again. Right, let me type now HTTPS : 192.168.1.1. Yeah, HTTPS is there, right? So it responds. So that's how you get to know you have this, ports are working. Now, if you have port 21 open, what do you mean? What does it mean? FTP is running. Port 22, SSH is running, right? Port 23, Telnet is running. So that's how you map using your, find out information using a scanner. And not only that, Nmap, the one that we are using now, is a really powerful tool where you can, write your own scripts. For an example, in order to understand whether in between your scanner and the target, there can be a firewall. How to find out? We have a technique called firewalking to gather information related to firewall, right? So in order to do that, you have special option. If you click on profile, edit profile, we have scripting here. There are a number of already written scripts are there. So you can find out scripts there. And if you improve and became sort of a really good script writer, you can use NSC or Nmap scripting engine to write your own script. Even you can do brute forcing, password hacking, anything. If you want to, you can write to your own script. So these are already created scripts. For an example, if I show you firewalking, firewalk. If you enable that, it means the command is nmap -- script firewalk. Then it will perform the task. And also, if you find there are multiple options, there are FTP brute forcing, even FTP, you can brute force. FTP brute is brute forcing FTP, right? So you can find out the password auditing against FTP servers. You can run it and see whether the password complexity is sufficient. And all these you can find out there. Heaps of tools there. You can run this script, right? So if you want to, you can just click on and you can just add it, right? Sorry, this is NSC networks. Nmap scripting engine. You need to open it up and you save this, and then you can start scanning, right? So here you would see Nmap FTP brute, right? So if you go to scans, you can find out this information. If I click on that, you would see the earlier one, right? This is my earlier scan. And from that, it found out this information, right? So it found these ports are open. 443, 80, 53, 5060 open, right? And also within FTP, DNS bind working. Now you need to know a bit of information related to this. The bind is open source DNS daemon, right? So if you find this something like this, let's say NSD DNS NS daemon bind version DNS. So just surf, Google it and see it's open source DNS version, which means my gateway has DNS service running with open source, right? And then port 80. So again, it's open, and these are information related to my website. So it has a website, and this is, information in my HTML here, right? And then content type and all that. And then again, it has 443 OpenVAS server running. So OpenVAS is again vulnerability assessment, open source vulnerability assessment tool. Probably a tiny version of OpenVAS is running in my gateway, right? So it's really important to understand that. And also these are server fingerprint. right? And there you can find the operating system related information here. You're right. Operating system should be Cisco UC320, right? And also it runs with Linux 2.618, 95% confirm, and then it should have Riverbed Steelhead proxy server, right? So you can find out all this information. And also, if you notice, these are actually guesses, because just by acquiring a port, you can't exactly say the operating system. But depending with the response, and not only three-way handshake, there are certain other stuff like window size, response type, a TTL value. Taking everything to consideration, Nmap can predict this should be this operating system, right? It can't say 100%, but it says, if you notice here, it says guessing, right? Guessing Linux 2.6x, right? 98% confident that this is Linux, right? And then Cisco embedded. It gives us so many guesses, because all these operating systems have built on top of Linux kernel. So it says 95, which means it cannot be anyway Windows, right? But 98% a different Linux version. So now you are gathering information, and then the scripts running and all that. If you go to ports, it would show you the number of ports, and it has SIP, session initiation protocol, where VoIP services would use, and TCP wrap 53. TCP wrap is a firewall within Linux, so we can gather all this information. I think it's you understand that, and the topology here, you would see the topology and host details. So it's a Cisco U320 PBX Linux 2.6 version, and the ports used. So you can find out all this information. And I think it's clear by now. So if I have a look at my Kali one, the open the command line one, again it shows these information. So we run here actually 1.3, right? Our ZenMap version or GUI version, we use 1.1. So here it should be running a Windows version. It says running Windows XP or Windows 7, and it should be Windows 7 Enterprise. And then scripts, the running the scripts that we have run, it shows, and these are the open ports. And 913 meaning it has VMware, and you can find out all this information here, right? So this is how we can perform scanning. So scanning give you more specific information as to how your target works, right? So I hope you understand